Okay, so we're going to learn two new formulas, rules, theorems. So, Rolle's theorem. And then I usually sing, Michael, roll your boat ashore. Hallelujah. Michael, roll, roll. Oh, whatever. Okay, anyways. So, Rolle's theorem. You're too young. It's a kid's song. Michael, row your boat ashore. Really? Okay, thank you. Roll, roll, roll your boat. Gently down. That doesn't quite work. Merrily, merrily, merrily. Life is but calculus. Okay, let f be some differentiable function on some interval a to b and continuous on that closed interval a to b. So let if f of a equals f of b equals 0. Okay, so what I would like you to do is to draw a coordinate grid down here and mark 2 points on, I'm using a ruler. Oh, that wasn't very good. Okay, mark 2 points on your x-axis, please. Make sure that point A is somewhere on the left and point B is somewhere on the right. Anywhere you would like, but they have to be on the x-axis. That's what f of A equals f of B equals 0 is saying. You have 2 points on the x-axis. We'll have that one as A, f of A, and B, f of B. Okay, so what I would like you to do is to join those two dots up with a continuous function that is differentiable over that interval. So draw me a nice smooth curve. Don't be boring. Be a little bit exciting. So it's kind of hard. How's that? You can have as many bumps as you would like, but my bumps, Spencer Lord, what am I going to do with you? Okay, then there is it. Oh, of course I'm recording this. I'm expecting. Yeah. Would you like to come closer to the microphone? So what Rolle's theorem says, it says there is at least one point C somewhere between A and B where the slope is 0. So what I would like you to do is to take your ruler, make it have a slope of 0, and slide it up and down to find those points C. So visualizing, it's hard to record this, but visualizing you have to see, there's the slope of 0, slide your ruler up and down, go looking for those points C. Yeah, just put a little dot where that happens, or a little point. Mark. Yeah, take a look at it. Holy, that's not quite differentiable there, though. Like that's not a sweet curve. If you zoom in on it. Okay. I'm a little scared there. I don't think it's differentiable at those points. Okay, good. Because if it wasn't, I'd be upset. Okay, so we would call this point right here C1, and we would call this point right here C2. Well, it says, Rolle's theorem says there is at least one. Yeah. So I have 2 C's, you have 3 C's. Spencer is geographically correct. He's got 7 C's. Seas, oceans. I don't know. We got the yellow sea and the black sea and the Arial Sea and the Red Sea and. Okay, it was weak. I was trying. Okay, so that's what Rolle's theorem says. Yeah. He is. He is. if C is some number defined by Rolle's theorem, then so they're saying it works in this interval 0 to root 3, then C is. So what we're trying to do is to find AC over the interval 0 to root 3. So all we need to do is to take the derivative, 6x squared minus 6, make it equal 0, do 0, and solve for x. Solve for x, please. So you get 6x squared equals 6, x squared equals 1, x equals plus 1, x equals minus 1. And then you throw one of those nth squares out. The negative, how come? Not in the domain, not in the interval. So the answer is A. Because that's what Rolle's theorem says, is the slope is 0. There are actually some things we need to check. If I was being very particular, we would need to show that the y values at 0 and at root 3 are 0. We would need to show that the function is continuous and differentiable over that interval. So we would have to make sure that we're not dividing by 0, we're not logging a negative number, and we're not square rooting a negative number. You need to actually make those statements first before you actually go on to show that you find the point C. But because we said it's defined by Rolle's theorem, so we're assuming all those things to be true. Okay. But the next question actually tests. This is a knowledge question, but it's not an easy. Well, it's an easy knowledge question if you know the definition of Rolle's theorem. But so it would be and is continuous on the interval, then the function must always be 0? No. There may be, the derivative might be different from 0 everywhere? No. There exists at least one number C being between A and B, such that the derivative equals 0? Yes, that's Rolle's theorem. And then D, I don't know why D is there because it's almost true. F prime of x must exist for every x on the interval A to B. Well, that's, but it is true, but the problem is this needs to be up with the condition here. This and this and this. Actually, the answer is E. C is almost right as well.
Because C, it could be A is less than C is less than B.
No. No, because Rolle's theorem, right, the answer is D. The answer is E. The answer is E because Rolle's theorem has 3 conditions to it. It must be continuous, right? It must have y values of 0, and it must be differentiable. And then if all of those 3 things are true, yeah, I even got sucked in. Then those 3 things must be true for Rolle's theorem to be true. F prime of C equals 0. Or 1 or 2 or 3, yeah. Yeah, that's how I would. I hate that. No, I would say A only, I, or I and I, or I and I, or, you know, like that kind of thing. But I just want you to make sure that C isn't true unless this condition is in here. That's sneaky. No, I got it off a friend. These are a friend of mine's notes. These aren't mine. I don't have time for that, to do this.
So if it's a bad instead of a continuous one, isn't it like differentiability implies continuity? Yeah.
No, but if, okay, yes, but look at how we've defined Rolle's theorem. It's very explicit. Continuous, differentiable, y values being 0. If those 3 things are there, then you can say Rolle's theorem holds. and this happens. So you need to have those three things there. They only had two of the three there. Does differentiability implies continuity, but continuity, right? But it doesn't say. Does it say it's differentiable?
No, it doesn't, but I'm saying if it did say it was differentiable and not continuous, and then saying it was continuous, would it still be true and have to be? Because
Yes. Yes, but you're making it trickier. I don't think that that level of sophistication is needed. Good point, yeah. If it's continuous, then it's differentiable. Sorry, if it's differentiable, then it's continuous. No, even removed. No, but it's not differentiable at that point. Okay. Mean value theorem. So the Rolle's theorem is kind of a small subset or a small little, the math word is corollary of the mean value theorem. Corollary. C-O-L-L-O. I can't spell. Corollary. 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 No. Okay. Oh, no. Okay. Draw me another coordinate grid. Corollary. I can't spell. You guys know that. Okay. I would like you to mark 2 points anywhere in space on these axes. Anywhere. It doesn't have to be on the axes. Anywhere in space. Just make sure that A is to the left of B. That's it. That's the only condition I have for you right now. So mark 2 points in space. A is on the left. B is on the right. Anywhere? Yeah, anywhere. And then B is, I don't know, here. Okay, I would like you to join A to B with a continuous curve that is differentiable everywhere. And please don't make it trivial because that's boring. Non-trivial. Don't draw a straight line. Well, then it's not a straight line. Yeah, but then there's problems maybe because you're creating corner points, and I don't like that. So I'm going to draw something really boring. A parabola. Okay. I would like you to join A, f of A, to B, f of B, with a line. Now, what is this yellow line called? Secant line. It is. It's also the average slope. So that's the slope of this line. Okay, what I would like you to do, this is why I asked you to have a ruler. What I would like you to do is to take your ruler and place it along the slope of that line. So join A, f of A, and B, f of B with your ruler, and hold your ruler there. Now what I would like you to do is to slide your ruler up and down with the same slopiness, and go looking for the points C that have that same slopiness. So if I slide my ruler down to about here on my curve, would you agree that that yellow line and that pink line are parallel? I just found a C. How many C's could this have? An infinite number, but how many do you guys have? Maybe 1 or 2 or 3, 4. That's exciting.
I have
12 and a half. You win. A little competitive, are we? So what that's saying is, the slope, the average slope, must also have some point somewhere where the instantaneous slope is the same. So in physics, we can make a connection if I drive from here to Vancouver and I know my average velocity, here's a good one that I used to ask a lot. That's right. So if I drive to Vancouver, and Vancouver's about 330 kilometers away, and I do it in 2 hours, my average velocity is 165. So that means my speedometer must say 165 somewhere during the trip. That's okay. If you drive along the highway, you don't see it too much anymore, but you used to see those really thick white lines along the sides of the road. What they would actually do is have planes flying overhead, and they would time when you break that yellow line, and then a certain distance away, the time when you break that yellow line, or the white line again, and then they would look that number up on the chart, and that would be your average velocity. And based on that average velocity being equal to instantaneous velocity, they can give you a speeding ticket from a plane. Yeah. Speeding kills, dude. Yeah. Oh, I don't know. They don't do it much anymore. They don't do it as much anymore. The cost of aviation fuel is really expensive. So that's why they went from. But that's why they went from. But they used to go. Okay, so they used to do this instead of radar vans. You would see a little Cessna flying up above on the highway, and you'd go, "Oh, I better slow down." Wouldn't. No. Okay, flip the page. Could you speak a little louder into the microphone? They're illegal to operate in BC. Okay. Well, we won't talk about that. Okay. So let f of x equal x cubed plus 1. When x is 1, y is 1 cubed plus 1, 2. So 1, 2. No, I can't count. When x is 2, y is 2 cubed plus 1. Y is 9. And then I would like you to join this with a continuous differentiable all everywhere curve, because x cubed plus 1, you never divide by 0, you don't square root a negative number, and you don't log a negative number here, so we know the curve's got to be nice and smooth. And because I took Math 11, I know that this kind of looks like that. And then I would join it up with a yellow secant line. Secant line. The slope of the yellow secant line is 9 minus 2 over 2 minus 1. And m is 7. So that's the first part of the mean value theorem. Find the slope of the secant line. The second part of the mean value theorem says take the derivative. Make it equal the slope of the secant line. Solve for x. Plus or minus the square root of 7 over 3. Which one do you keep? Plus. Why? Because it's in the domain. It's in the interval that you're interested in. Negative root 7 over 3 is not in the interval. So C is, therefore C equals C equals the positive root of 7 over 3, which is about 1.5. And actually, if you take that yellow line, you slide along that black curve at about 1.5, it'll have the lines will be parallel. Okay. The function f of x on the interval -8, comma, +8 does not satisfy the mean value theorem because f of 0 is not defined. Won't put 0 into that function. 0 to the 2/3 power. 0. So that's false. Okay, B, f of x is not continuous on the interval. Well, I'll draw that function. Oh, you're starting to think. Which one is it? Which one is it? It's a cos. So is it f of x is not continuous on it? That's false. F prime of -1 does not exist. Yeah, it does. That's false. F of x is not defined for x is less than 0. No, there's a graph there. E, f prime of 0 does not exist because it's a cos. Cos. This is true. Now, how do I know? Let's pretend I didn't draw this picture. Let's pretend that I didn't give you this graph, or you had access. You did not have access to your graphing calculator for this question. If I took the derivative, f prime of x equals, or f of x equals x to the 2/3. So f prime of x equals 2/3 x to the -1/3. You would write it as 2/3 times 1 over x to the 1/3. What are we not allowed to do? Divide by 0. X equals 0 is either a cusp or a vertical tangent. When the bottom equals 0, you're creating cusps or vertical tangents. You don't know which. Actually, I do, but I'm not. If the power, okay, if the numerator is even on the fraction that you start with, if the numerator is even on the fraction you start with, 2/3, you're creating a cusp. If it's odd, you're creating a vertical tangent. Yeah. Because when you square something, it makes it positive. So instead of having a vertical tangent, you take that bottom part and just flip it up next to it. Take a vertical tangent and take this part and reflect it up like an absolute value graph. Creates cusps.
So you don't have to do that section.
Well, I wouldn't even memorize. All you got to do is remember that when you take the derivative, there's two kinds of critical points. The ones that make the top equal 0, there aren't any here, and the ones that make the bottom equal 0. Bottom equal 0s are bad. Either vertical tangents or cusps. But you got to remember what the mean value theorem says. It's got to be continuous and differentiable everywhere. Vertical tangents and cusps, you're not differentiable there. Okay. Anyways, show that, okay, so you can do this one. Show that the function satisfies the hypothesis of the mean value theorem on the interval 0 to 2, and then find a solution for C. So find C. So you have to check things. First thing, 1, you have to make sure that it's continuous. 2, you have to make sure that it's differentiable. So you have to make a statement that's saying that this is continuous and this is differentiable. Is it? Yeah, it's pretty trivial, Mr. F. It's y equals x squared. Ooh, bravo, right? So it's continuous on the interval. It's differentiable on the interval. So we satisfied 2 of the statements about the mean value theorem. Now what do you have to do? Find C. Okay, so you have a whole bunch of things to do. What do you have to do first? Okay. Got that done. Now what do you have to do? make it equal what? Slope of what? So has anybody talked about the slope of the secant line yet? So how do you find the slope of the secant line? F of b minus f of a over b minus a. Well, what's f of b? I don't know, because I was excited. What's f of b? How'd you get 4? F of 2 minus f of 0 over 2 minus 0. 4 minus 0 over 2 minus 0. So, the slope of the secant line is 2. Now what? So 2. So do what? So 2x equals 2. Solve for x. There you go. So what's c equal to? 1. There's only one c, Mr. Epp, and it's c equals 1. And you're done. No. Yeah, you put 2 in for x. So 2 squared is 4. Yeah. How's that? Cool? Okay. So, interpreting the mean value theorem. A car accelerates from... What? Oh, sorry. Where? Oh, applying the mean value theorem. We just did it. Applying the mean value theorem. So f of x, a equals 1, negative 1 comma f of 1, and b comma. Okay, so we better make sure that we're not square rooting a negative number between negative 1 and positive 1. And we're not. Because between negative 1 and positive 1, our x values are small. And when you square a small number, it gets smaller. So 1 minus a number smaller than 1 is positive, so that's okay. So it's continuous. It's also differentiable because when we take the, we'll find out when we take the derivative. There are no corners or cusps or vertical tangents in that domain. Well, we'll find the derivative. We're going to do that right now. So the first thing we probably should do is find out what f prime of x is, hey? F of x equals 1 minus x squared to the 1/2. So when you take the derivative of that, you get a half. 1 minus x squared to the negative a half times negative 2x. Make it look pretty so you can talk about its derivative. So you get negative x over root 1 minus x squared. Okay, 2 kinds of critical points. Tell me what value of x that makes the top equal 0. Tell me what values of x that make the bottom equal 0. Okay, but look at how we wrote the domain, kids. So, do we even care about the gray answers that I have up on the screen? Not in the domain, don't care about them. Oops, why do we need to do that? That's dumb. I'm stupid. Okay, not in the domain, we don't care about them. What? Oh, those are, yeah, okay. So these are bad. Okay? Okay. So now what we need to do is to find our y values. No. I got excited and I was like, I don't have to do that. Okay. How do we find the slope of the secant line? Throw in 1 for x. 1 squared. F of b minus f of a over b minus a. I got excited. I think we're going to use some of this answer that we did up before. What's f of b? What's f of 1? 1 squared. 1. 1 minus 1. 0. Square root of 0. 0. Now we're going to be excited. And then we're going to put negative 1 in. Negative 1 squared, positive 1, 1 minus 1, 0, square root of 0, 0. I'm just having fun. Over 1 minus negative 1. So we got 0 over 2, which is 0. Okay. Let me kill all this. So what we need to do is to take this answer and make it equal our derivative. Can you see why I got ahead of myself? I'm sorry, I apologize. When you're solving equations, the only part you're interested in is what values of x that make the top equal 0. 0. That is the only value. When you're solving an equation that looks like this, sure, but this won't ever equal 0. What we're only interested in is that. So who cares what the denominator is? Doesn't matter. As long as it's all over one denominator, who cares what the denominator is? I was the kid in class that did this. I just got rid of the denominator. Multiply both sides by, hey, I got the right hand side. No problem. So all we're interested in is negative x equals 0. Therefore, x equals 0. It's parallel to the secant AB. But you should have said, Mr. F, that's just Rolle's theorem. Because your y values were 0, so you could just go back to the easier one, Rolle's theorem. You don't need to make it as complicated. Okay, sorry. Last one. See if you can figure this out. The car accelerates from 0, takes 8 seconds to go 352 feet. What is its average velocity? Eight seconds, 352 feet. 41 feet per second. What? So you'd go 352 feet divided by 8 seconds equals 44 feet per second. Okay, explain why this means at some point during the acceleration your accelerometer, your speedometer must say 30 miles per hour. Well, 44 feet per second, the mean value theorem. Yes. The intermediate value theorem talks about y values. The mean value theorem talks about slope. So 44 feet per second, how many feet are in a mile? 5280. So I have that number memorized. There are 5,280 feet in 1 mile. 5,280, 1 mile is 5,200, no, I have it memorized. No. So, how many seconds are in an hour? So, 44 times 3,600 divided by 5,280 equals mph. Now, why? Because the mean value theorem says that the average velocity must equal the instantaneous velocity at least one point c. Yeah. Yeah. It would be really kind of bad if you were accelerating and it was discontinuous. Somebody drops a clutch, pulls on the e-brake, hit a brick wall. Okay, that's it for today. Yay.